Hi, welcome to our CompTIA Cloud Plus course. In this lesson, we will talk about virtualization concepts covering the following topics, such as the VM components, CPU and memory, virtual disks, VNICs, and other devices. Okay, so virtualization has been around, right, for a very, very long time. It's been here for a while. It's only growing. If you have managed a server environment, you may mostly notice the average memory and CPU utilization of the servers. Some is like 40%, 30%, or worse, just 10%, which is very, very low. So you see what's the problem here. With virtualization, we can take advantage of the actual power, increase the average load of our resources that we paid so much for that are already inside of our physical server. Now, if you look at this figure, right, here at the bottom, you can see that we have three different servers with different services and operating systems with its own dedicated hardware. Did you notice that the average utilization is low, right? So 30%, 40, and 10. Those unused resources cannot be used for new server requirements, such as for a new application. Now, with the figure on top here, our web server, app server, database servers can be converted to virtual machines. These virtual machines will be managed by a hypervisor, this one, which is sitting on a cluster of physical hardware. Additional application requirements does not incur additional cost as long as there is enough hardware resource on the hardware cluster. Now let's further talk about what virtualization really is. First concept about virtualization is server mobility. So deploying servers using virtualization is more flexible. Each virtual machine can be relocated from member physical server cluster, or what we call as a host, to another. This happens if a member server where this VM sits fails and need maintenance. Next important concept are hypervisors. So the key element of virtualization is a hypervisor. It allows a system to abstract operating systems and applications from the physical server hardware. This allows the underlying host machine to independently operate these virtual machines as guest VMs. So what are the benefits of hypervisors? First, virtualized hardware interface to the operating system. Hypervisor provides a uniform virtualized hardware interface to the OS, which is installed above the virtualization layer. It separates the physical hardware into multiple resource units. So here, it separates the physical hardware into multiple resource units that all draw from the physical pool. You can run multiple instances of a single operating system or different types of OS running simultaneously on a single server. And of course, simpler administration. The virtualization layer can provide additional management options for interacting with systems running on a VM. And this makes administration of the system so much easier. Now let's talk about the VM components. So VMs as a logical container, right? So a VM is a logical entity hosted on a virtualization server. It's a logical container that holds all resources that an operating system needs to operate. These resources can be graphics, adapter, memory, processor, networking, and so on. As far as the OS system running or operating system running in a VM is concerned, there's no difference between these components and the components that would be available in the physical server. VM hardware specifications of VMs also have hardware specs. However, in the VM environment, some hardware specifications vary according to the physical resources that are available in the pool. There are four primary resources needed to run a VM. First, you have to have a CPU and memory, then virtual disks, virtual NIC or network interface cards, and other controllers, such as if you want to install an OS using an ISO file. Now let's talk about the specifics of each of the components. So first one is the CPU and memory. So the CPU and memory directly affects the VM performance. So CPU and memory are the two components that are directly affect the performance of the VM. They're also the two resource types that are most dependent on server physical resources. So remember the time when your laptop is running with only 4 GB of RAM and a very old, slow Intel processor, and every task seemed to take forever to process. So ensuring that you have sufficient amount of CPU and memory gives you assurance that your VM will run properly. On this illustration, right, so as you will see, we have the CPU and memory, which are actually virtual resources. So this figure, it shows the relationship of the physical CPU and the memory to the operating system within a virtual machine. CPU and memory are both assigned virtual resources of a VM. The OS will detect the CPU and memory as if these are physical resources. The OS is unaware that it's running on a virtualized environment and will just rely on the assigned resources to the VM. Another critical concept, by the way, is that do not oversubscribe resources on a VM. Note that it's not efficient to oversubscribe the resources by assigning more to VMs than what is available in the physical hardware. Let's talk about the virtual disk. Data stores and VMDK files, right? We're talking about that. So a VM has a set of containers called data stores. For each VM, a specific amount of space from one of the data stores is available that contains all the files in the VM. So this figure, as you will see, shows an ESXi host, right? With a data store that contains VM in a virtual machine disk with an extension name of .vmdk here. Whenever you create a new VM, resources such as CPU, memory, and disk size must be assigned. We also have what we call as disk modes. So there are also a couple of virtual disk modes specifically with VMware, and these are dependent, independent persistent, and independent non-persistent mode. All these three modes basically are different behaviors of virtual disk when a snapshot is taken. Now let's talk about disk modes. First one is dependent disk modes. Dependent is a VMware default disk mode, which means that when you take a snapshot of a virtual machine, all disks are included in the snapshot. When you revert back to the previous snapshot, all data are reverted back to the point of taking a snapshot. Next is independent persistent mode. So disks in persistent mode behave like dependent disk mode, except all data written to a disk stays permanently even if you revert back to the snapshot. For example, you have added a new disk to a virtual machine and you want to keep all the data permanently even in the event of reverting back the snapshot. Persistent mode is good. For example, if you want to keep some logs or data permanently, so you can have log data consistent even after reverting snapshot back in time. Third is independent non-persistent mode. So non-persistent mode is the best way to describe a read-only virtual disk. When a new file is created, data is not written to a disk but to redo a file. And in the event that the virtual machine is powered off or a snapshot is deleted, all data is discarded. Okay? Let's talk about VNICs or virtual network interface cards. A virtual network is an interface between the virtual machines that exit from the ESXi host and enter the physical network. So determining the type that is used typically depends on the type of guest operating system and applications that are installed. Note that there are several options available that enable VMs to reach the network. So in this illustration, right, you're looking at the VNIC or the virtual network interface card at this part of the illustration. One concept here is the VM network adapter. So when creating a new VM VNIC adapter, there are several supported options from which to choose. The choice is important for the guest operating system to properly detect the virtualized hardware. There can only be max 10 VNICs per VM. So remember, a maximum of 10 VNICs are allowed per VM, but only one is typically used. So only one VLAN or port group can be used on each VNIC. In terms of the other devices, we have IDE, floppy, and SCSI. So there are different types of controllers, right? And this can be IDE or integrated drive electronics, floppy, and SCSI. The VM can mount one or more of these disks and drives. And now instead of using physical media, software images, CD-ROMs, or floppy drives can be mounted. So this figure shows you how the physical resources are connected to the VM through the hypervisor virtualization. Some other devices like NVMe and RDMA, so several new features were added to the new VM format version 13 in version 6.5. And these features include support for the high-performance virtual non-volatile memory express or NVMe, and RDMA, the para virtualized remote direct memory access. Third is USB 3.0 and vGPU, so the support of USB 3.0 in virtual graphics processing unit cards was added in vSphere 5.0. Okay, that's it. That's the end of the lesson. Here we spoke about virtualization concepts like the components, CPU and memory, virtual disk, Linux, and the other devices. Thank you very much for watching the video.